Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 5 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2579. Count total number of colored cells. Okay, so let's read the problem statement first. There exists an infinitely large two-dimensional grid of uncolored unit cells. You are given a positive integer n, indicating that you must do the following routine for n minutes. So at the first minute, you are going to color any arbitrary unit cell blue. Okay. Every minute thereafter, we have to color blue every uncolored cell that touches a blue cell. Okay. So below is a pictorial representation of the state of the grid after minutes 1, 2 and 3. Okay. So at first minute, we just painted this cell to blue color. Okay, so if my n value is 1, so I'm going to return my output as 1. Okay, so now in the second minute, okay, when my n value is equal to 2, okay, so initially I colored this blue, right? So now this cell is going to touch this cell, right? So I'm just going to paint this to blue. Okay, then this uncolored cell is also touching this blue. I'm going to paint it to blue. This uncolored cell is also touching this blue. I'm going to paint it. This uncolored cell is also touching this blue. I'm going to paint it. Okay, so at n is equal to 2, I have to return output as 5. Okay, there are total 5 cells which I have painted, right? Done. Now here for n is equal to 3. Okay, so at n is equal to 3. Okay, so initially at n is equal to 2, we have these cells painted as blue, right? This and this and this. Okay, so now in the next minute, okay, at third minute, I see that this uncolored cell is touching this one, this uncolored cell is also touching this one, this uncolored cell is also touching this one. So I'm going to paint all this blue. Okay, this to blue, this to blue. Okay, same way for this one, this is touching, but I have already painted to blue. Okay, this cell I'm going to paint to blue, and this cell I'm going to paint it to blue. Okay, done. Then for this one, this is I'm going to change it to blue, but it's already blue, so I'm not going to make any changes here. So this uncolored cell is also touching this blue, so I'm going to paint it, and I'm going to paint this as well. Okay, now for this B, this is I have already changed it to blue, this I have already changed to blue, and this cell is also touching this, right? So I'm going to change it to blue. Okay, so at n is equal to 3, my output is here. See here, total 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so n is equal to 13, we have 13 as output. Okay, n is equal to 3, we have 13 as output. Okay, so we have to just return the number of colored cells at the end of n minutes. So we have one n value given to us, and for that n we have to return the output. Okay, so here first thing that we have to do, we have to recognize the pattern here. What is happening here? So at n is equal to 1, okay, at n is equal to 1, my output is 1. Okay, at n is equal to 2, if you see, my output is 5. All right, at n is equal to 3, my output is 13. Okay, done. Then if you calculate for n is equal to 4, okay, so for n is equal to 4, uh, total of 13 cells are right here. So here I will add 1, so 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 and 25. Okay, so for n is equal to 4, my output is going to be 25. Done. Okay, so here see one pattern. So here at n is equal to 1, output is 1. At n is equal to 2, we have output is 5. So what is the difference among them? Difference among them is 4. Okay, done. Then here at n is equal to 2, output is 5. N is equal to 3, output is 13. So difference here is 8. Okay, then here 13, and then we have 25. So see the difference here, it's nothing but 12. Okay, so here if you see carefully, so what did I notice here? First at n is equal to 1, we have 1. So here we are adding 4 cells. Okay, so here see, calculate, see 1, 2, 3, 4. Okay, 4 new cells. Nice. Then check this, 1, 2, 3, 4, 5, 6, 7, 8 new cells for 3. Okay, so I recognize this pattern here. All right, so here if you see, first difference is 4 again. Okay, so in between the difference is just a multiple of 4. Okay, so here initially here I'm going to drive one formula. Okay, so what is going to be my formula? 4, okay, into here I minus 0 plus x, okay, and here x. Okay, so we have a value starting from 1, right? So if you see the constant size here, so n ranges from 1 to 10 to the power 5. Okay, so here I can derive one formula, right? This formula. So here now just check this formula. Okay, what I'm going to do here, it should be I minus 1, I not I minus 1. Okay, so now here see, at I is equal to 0. Okay, at I is equal to 0, that simply means at 0 minute. Okay, so initialize just x to 1. Okay, initialize x to 1. Okay, so now here when my I is 0, I is 1. Okay, initialize I as 1 as well. Okay, so now when my I as 1, okay, I is 1, so here I will get output as 1 minus 1 plus x is 1. Okay, so I will get output as 1 for my n is equal to 1. Okay, for my n is equal to 1 or I is equal to 1. Okay, at I is equal to 1, my output is 1. Okay, so in the question statement we have n given, so you can take n also here. Okay, so but let's take I. Okay, so here after the end of 1 minute my output is 1. Okay, now at after the end of second minute, okay, 2 minute, so here just update the 2 value here in place of I. So 2 minus 1 plus a previous value of x. So this is a previous value of x, which is nothing but 1. I am getting 1 here. Okay, for I is equal to 1. So again here I am going to add 1. So I will get nothing but 5. So 5 is the output for I is equal to 2. Okay, now for I is equal to 3. So 4 into here I is equal to 3 now. So 3 minus 1 plus previous value of x. Previous value of x is 5. So here I'm going to add 5. So 4 into 2 is 8. 8 plus 5 is equal to 13. Okay, 13 is the output for I is equal to 3. All right. Then for I is equal to 4, if I check, let's say I is equal to 4. So 4 into 4 minus 1 plus previous value of x is 13. Okay, so here 4 into 3, 12. 12 plus 13 is equal to 25. Okay, this is the output. So this is the formula that I have derived here. Okay, so first let's solve this problem using this formula, then I will derive one more formula here from this. Okay, so first let's solve this problem. So we have return type as long, so here I'm just going to create one variable long x is equal to 1, and then after that I'm going to run one loop. Okay, so int I started from 1 and I should be less than equal to n. Okay, after the end of this nth mint I will just calculate the x value. Okay, updated x value. So how I'm going to update x as, so I'm going to update x as x plus 4 into, and here I'm writing I minus 1, right? This is what we have discussed, right? And now after that just return x. So now let's run the code and see if there are any code issues. So see, all the test cases has been accepted. Now let's submit it. So this is going to be my approach 1, and this in this approach 1, if you see, my time complexity is going to be of n. Okay, so now can I solve this problem in of 1 time complexity? Yes, I can solve this problem. Okay, so now little bit we have to modify this formula now. Okay, so I hope that you guys are clear with this formula. So now I'm going to solve this problem in of 1 time complexity. Okay, so here if you notice here, so initially I have this value 1, okay, for 1 minute. Okay, and then after that in the next minute I am adding 4 to this one and I am getting 5. Okay, then after that I am adding 8 to this 5 and I am getting 13. After that I am adding 12 to this 13 and I am getting output as 25. Okay, so here if you notice one pattern here. Okay, so 1, okay, I can write it like this: 4 into 1 plus 1. Okay, this is how I can write this. Okay, and this here I can write it like this: 4 into 2 plus previous value, which is nothing but 5. Okay, and here I can write it like this: 4 into 3 plus previous value, which is nothing but 13. Okay, so this is what's happening right here. So let me just remove this plus icon. Okay, so this is what's happening, right? Here I can write it like this: 4 into 1 plus previous value. So here 4 into 2 plus previous value, which is 5 coming from here. And then here I can write just 4 into 3 plus 13. Okay, so you notice that here the difference is 4, difference is 8. Okay, for the next step, and here difference is 12. Okay, this we already aware, right? So here let's recognize this pattern. 1 plus 4 plus 8 plus uh, here 12. Okay, so now this is what's happening, right? So at n is equal to 1, output is 1. At n is equal to 2, output is 5. Okay, at n is equal to 3, output is 13. At n is equal to 4, output is 25. Okay, so this is what's happening, right? 1 plus 4 is 5, 5 plus 8 13, 13 plus 12 25. Okay, so this is the pattern: 1 plus 4 plus 8 plus 12, right? Okay, this is a pattern. All right, so now here I can also write this pattern as 1 plus 4 into 1 plus 4 into 2 plus 4 into 3. Okay, then also you are going to get the same thing. Okay, at n is equal to 1, output is 1. At n is equal to 2, output is 5. At n is equal to 3, summation of all these, you will get output as 13. At n is equal to 4, you are going to get output as 25. Okay, done. So now here I can also write it like this: 1 plus 4 common, and inside this 1 plus 2 plus 3. Okay, I can write this like this as well. Okay, 1 plus 2 3. So here 1 plus 4, and this is a number series, right? You know one thing, like what is the summation of the first n natural numbers, right? So in mathematics you know what this, right? 1 plus 2 plus 3, and let's suppose we have numbers until n. So how we calculate the summation of these n numbers? We are going to write it like this: n into n plus 1 divided by 2, right? This is how we write. So here let's suppose I want to calculate the sum of this: 1 plus 2 plus 3. Okay, so in that case I am calculating the summation of first three natural numbers. Okay, so here if I put 3 here, 3 into 3 plus 1, which is 4, divided by 2, so I will get output as 6. Okay, and this 6 is right now. 1 plus 2 plus 3. Okay, 6. Okay, but here, okay, this is done, but here we are not calculating the summation until n. We are calculating the summation until n minus 1. Why? Because here we are taking one extra value here, right? So if n is equal to 1, then this is going to be my output. Okay, this one. And here uh, we are not considering this. Okay, so if n is equal to 2, then only we are considering until here. Okay, so that simply means that until here we have n minus 1 values. Okay, n minus 1 values, and here we have one value. So if I do the summation of this n minus 1 values here and plus one extra value here, so I will get total n. Okay, so this is what we need to find. So here I'm writing one value, and here I'm writing n minus 1. So I have to update the formula here. Instead of n, I will use n minus 1. So here I will modify this n as n minus 1, and here n minus 1 plus 1. So then it will become n minus 1 into this cancel out each other, and divided by 2. Okay, so this is a formula. So here just place this value for n minus 1. Okay, for n minus 1 I am placing this formula here: n minus 1 into n and divided by 2. Okay, now this 2 is going to cancel this, so here I will get 2. Okay, so my new formula is 1 plus 2 into n minus 1 into n. Okay, so this is my new formula, and this is going to give me output. Okay, simple one line, nothing else. Okay, 1 plus, and here we return type is going to be long, right? It's long, and here inside this I have to write 2 into n minus 1, and then into n. That's it. Okay, and this is going to give me the time complexity of O of 1. Okay, so now let's run it and see if there any code issue. We'll try to fix that. So the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.